Okay, hello, welcome to my channel. So in this video, we want to find the solutions to Math 111 2020/2021 past questions, right? So this video, I'm going to be looking at the test question for that session. There were just 10 questions, and we are going to be doing the 10 questions in this video. So this is just the first question, the second one, and then we're going to be doing third and fourth just after the second one, right? Okay, great. Okay, so here with me is McKay, all right? So McKay will be taking you throughout this video. So let's see what we have. So the first question here, we have to solve for x in the given equation. So the equation is given to be 2 to the power 2x times 9 to the power x raised to the power equals to 36 on the right hand side, right? Okay, great. So when we have an equation like this, we look at the powers there. In the power, we have x common. So of course, from the rule, indical rules, we can factor out a common power, right? So that means we're going to have 2 to the power 2 times 9, and then we take x common, right? Because x is common as the power. So you notice this is 2 to the power 2, which is the same thing as 4. When you multiply 4 to 9, we are going to have just 36 as the base, right? And then we raise it to power x, and on the right hand side, we just have 36. And of course, 36 raised to some power gives us 36. So you can see the power is not even there, right? So in fact, x, right there is going to be 0. No. X is in fact going to be 1, because 36 raised to power 1 remains the same. So that's the value of x from this quick equation. All right, so the second question real quick. Well, since this is just a past question, you know, we are not doing topic by topic. So you will tend to encounter a very easy question, and the next one may be a lot more difficult, like this one compared to the first question. We have to find alpha and beta, okay? Oh, we are given a quadratic equation here. Let me show you. This right here is the quadratic, right, where the necessary power or the highest power here is 2. Okay, and we are to find the value of alpha squared plus beta squared, that is the sum of the squares of alpha and beta, where alpha and beta are the roots of this quadratic equation. So you should know what we mean when we say some numbers like alpha and beta are roots. Their roots means they are solutions to that quadratic equation. That is to say, if you substitute alpha into the equation, you get 0, and also if you substitute beta, you get 0, which is just the right hand side. In other words, those are numbers, alpha and beta, satisfy the equation. Okay, so to get alpha squared plus beta squared, this is going to be really simple, right? But not as simple as the first one, because we have some things to help us. Things like the sum of the roots of a quadratic equation, right? When you have the sum of the roots, let's say alpha plus beta, we have that to be, well, negative b over a, okay? And then the product of those roots, alpha times beta, to be c over a. So what is a, b, and c from a quadratic equation, right? Okay, so given a quadratic equation, we notice that a is going to be the coefficient of x squared, which in this case is just 3, right? B is the coefficient of x, which is in this case is just negative 5. So you pay attention to the sign in front. And then c is the constant term, which right here is negative 1. In fact, in general, it should be of the form ax squared plus bx plus c, right? Should be 0. So when we notice that this is, instead of positive something, it's now negative of that, that means that the coefficient of x is just the coefficient of x, which is supposed to be b, is in fact negative 5 in this case. So we are going to use these constants here and then get the sum and then the difference, the product of those two roots, right? So you notice that alpha plus beta is going to be negative b. So negative of b is what? B is negative 5. So we're going to put negative 5 at the top, divided by a. A from that given equation is just 3, right, as I've written out here. So we notice what is the product. The product is supposed to be c over a, which in fact is going to be minus 1 over a, which is just 3. So as you can see here, the sum is negative of negative 5 over 3. Negative times negative will give us positive. So we can just have 5 over 3 right there, isn't it? Okay, great. So now we have the sum and then the product of those two roots. We are ready to find alpha squared plus beta squared. So in fact, let's just put that down. We have to find alpha squared plus beta squared, right? Okay, let me put this properly. Well, this right here is exact same thing as the square of alpha plus beta, okay, minus 2 times their product. Now, this is motivated from the fact that when you take the binomial expansion of alpha plus beta squared, okay, we have that to be the square of alpha plus the square of beta, okay, plus the square of beta plus 2 times their product. So that is to say, alpha squared plus beta squared will be this term minus this term, right? That is if you subtract this term from both sides. So you are going to have alpha squared plus beta squared, which is on the left hand side here, to be this term right here minus this term, right? And that gives you that. So that is really easy, isn't it? Okay, so given that, we are just going to substitute the sum and then the product where necessary. So as you can see, this is going to be, well, we notice this is just alpha plus beta raised to power 2. Well, what is alpha plus beta from here? We notice that that is just 5 over 3. So we are going to put in 5 over 3 and raise it to power 2 minus 2 times the product. Alpha times beta is in fact negative 1 over 3. So we're going to put in negative 1 over 3, isn't it? So this is going to be, well, we square this fraction, we're going to have 25 over 9, right? Say minus 2 times negative 1 will be positive 2 over 3. Okay, great. We just need to add these fractions, right? And then we get the sum. But I'm going to add this fraction by making it a lot more easier. I'm going to make the denominators to be the same. In that case, I'll have to just add the numerators and keep a single denominator. So what I did here was to multiply this particular fraction by 1. And the version of 1 is 3 over 3. So that if you multiply this, the denominators will be the same. In other words, we'll just maintain a single denominator and then we add the numerators. Isn't that very nice? We have 25 plus, well, 2 times 3 is going to be 6. So 25 plus 6 will give us 31. So this right here can be called the sum of the square of alpha and beta, right? Or if you like, you can change this to its mixed fraction form, which will be 3 whole number 4 over 9. But in fact, I would just like to stop here for the second question. So I'll clean this part of I'll clean the board, and then we are going to continue solving the third, fourth, and other questions, right? Okay, so let's just wipe the board. Okay, so let's just get on with the third question real quick. So here we are given the absolute value of 3x plus 1 to be less than 1 over 4, right? So this is an inequality, and this right here is an absolute value. And this tells us that this right here is in between negative 1 over 4 and 1 over 4. That is what it means to be inside the absolute value. Like, if we have a number, let's say a, to be inside an absolute value and it's less than b, okay, this tells us that a, in fact, lies in between negative b and positive b, right? That is, a is in between negative b and b. So a can be a negative number and a positive number, but it doesn't have to be less than negative b, and it's not going to be bigger than positive b. So we are going to use the same idea here. In fact, it is just the same thing, just that I made it simpler by replacing the notations. And that means we're going to have negative 1 over 4 to be less than 3x plus 1 to be less than 1 over 4. Okay, so what we're really looking for in this kind of question is to find the values or the set of values of x that will satisfy this equation. In other words, the set of values of x that will lie, that if we substitute here, it will allow this to be less than 1 over 4. Okay, so let's see what we have. Well, we try to isolate x here, all right, make x to stand alone here. That is to say, we are going to take every other thing out aside of it. So we are going to subtract 1 throughout the inequality so that we can clear 1 from here, right? So that means we're going to have, well, negative 1 over 4. 1 over 4. We subtract 1 throughout the inequality. We're going to have minus 1 to be less than 3x plus 1 minus 1, right? That means we're going to have just 3x. And we say that is less than, maybe I should use a negative sign to indicate that I just brought in this negative 1 because I was subtracting 1 throughout the inequality, right? Then we're going to have just positive 1 over 4 minus 1, isn't it? So you just need to compute this to see what you have. So when you subtract 1 from negative 1 over 4, you are going to have 5 something over 4. Let's see. Well, we're going to have minus 5 over 4, right? So you just check that out anyway. When you subtract, you know this is negative 1, which is the same thing as negative 4 over 4. So since the bases are the same, you can in fact subtract the numerators. Okay, so that's very nice. Let's just maintain the 1. So this is going to be less than, we just put in the 3x inside, and then we say this is less than. When you subtract 1 over 4 from 1, we're going to have negative 3 over 4. Right? Negative 3 over 4. Similarly, you can change this to 4 over 4. Okay, so since the bases are the same, you now subtract the powers. The numerators, sorry. You now subtract the numerators. So that's going to give you that. Anyway, that's very easy. Okay, so the next thing we'd like to do is to divide through by 3. Right? Because x is with 3. Remember, we want to make x to stand alone inside or anywhere. But here, it should just be inside so that we know which value is bigger than x and which value is less than x. In other words, we know where x lies. Alright, so that means we're going to have this to be, well, if we divide through by 3, we're going to have negative 5 over 12, right? To be less than, hope that is showing, okay? X, and this is in turn less than, well, this is going to be negative 1 over 4. So when you divide this by 3, it will now be negative 5 divided by 4 divided by 3, which is the same thing as that. And then we divide this by 3. Of course, that 3 will cancel out with this 3 at the top. We just have negative 1 over 4. So here we have just x staying alone inside the inequalities, right? Bounded by these two numbers. Negative 5 over 4 on the left-hand side, negative 5 over 12 on the left-hand side, and then negative 1 over 4 on the right-hand side. So in fact, that tells us, let me put this solution right here. That tells us that x lies in between. Okay, this is how you are going to write it. Maybe you can just keep it this way, okay? You can just keep it this way. But let's just say you have an objective type question, like multiple choice type question, where you need to choose the correct option, right? This may not be there, so you need to understand the notations, right? So you can say x is in between negative 5 over 12, maybe negative 1 over 4. Right, this right here are just parentheses because this is strictly less than. Right, if this was less than or equality sign, we will use this squared bracket, right, at the end point, or you can call them the silent point. But in fact, this is okay. This is totally okay. Fine. Okay, so that is it. That tells us that x, if x is in between that interval, then this right here will be less than, the absolute value of this will be less than 1 over 4. Okay, great. And now let's look at the fourth question real quick. So we have to find the fifth term in the expansion of a minus b raised to the power of 10. So we have a minus b raised to the power of 10. Well, we are looking at binomial expansion, all right? Suppose we are given a general term, let's just say x plus y raised to a power n, all right? This is known to be the sum. The expansion of this, right, is going to be the sum. Let's make use of r, as r starts from 0 to n of n combination r times, well, the first term here is just x raised to the power of n minus r, and then y raised to the power of r. So where this r here is the index of summation, so it will start from 0, we will substitute r equals to 0 and compute, gets to 1 to 2 till we get to n, where n here means the power here. So when we are looking at the sum, the question asked us to find the fifth term. If we are looking at the sum of the first 5 terms, we are going to make use of this summation sign. That is, when r is 0, you put in here and then evaluate, right? You add it with when r is 1, like that till the first 5 terms, which means when r is 4. Okay, but if you are just to find the fifth term, or maybe the sixth term, or maybe a particular term, you are just going to make use of this sequence right here. Does this without the summation sign. That means you are not going to be adding terms because you are just asked to find just a single term. So you will also notice from the sum that let's just say we want to find the fifth term of this. All right, so that is going to be a minus b raised to the power 10. Right, we want to find the fifth term in the expansion of that. So we are not being asked to expand this, rather we are just asked to find this fifth term. Now when we are talking about the first term, r will be 0. So first term, okay, r is 0. For the second term, we notice r will be 1 because here we're saying r should start from 0. So when it's done with 0, it will now increase to 1. Then we substitute r equals to 1 here. After evaluating, we now increase it to 2 and keep on adding, right? But what we are caring about is not the sum. What we care about is in the term. So when we are considering the first term, we notice that r will be 0. The second term, r will be 1. The third term, r will be what? Of course, 2, right? R will be 2. So for the fifth term, it tells us that r will be 4. So when we're looking at the fifth term, r will be 4. Good. So to consider the fifth term in this expansion, we'll be looking at, well, n here. take note, I said we should be using this, so that will be n, where n here is going to be 10, right? So you notice n was the power, so n must be the power, which is 10 here, and we take 10 combination r, where I'm saying r should be 4 when we are considering the fifth term, right? And then we multiply that by, well, x here means the first term, so the first term inside here, which is just a, raised to what power? Well, raised to the power of n minus r. In this case, it's going to be 10 minus r here is what? 4, right? And we multiply that by, well, the second term here is just y. Our second term here is going to be negative b, right? You notice this was positive, this is negative, because the b has a negative. So we call that negative b, and we raise it to power r, which in this case we are calling it 4. Good, so maybe I will just clean this part. Okay? This is going to be the fifth term of the expansion of this term right here. But this is not where you are going to stop. You will have to do some work on this, all right? So in fact, I will clean this place. We are going to put this here and then solve it properly. Okay, so we now have this, where you notice that 10 combination 4 means we are going to have 10 factorial. Okay, so this is going to be 10 factorial divided by, now when you have something, maybe n combination r, it means n factorial divided by n minus r factorial times r factorial. So we're just going to use the same thing right here. So there'll be 10 factorial divided by 10 minus 4 factorial, right, times 4 factorial. Okay, so we say a raised to the power of 10 minus 4 is just 6. Okay, so we notice this is negative b raised to an even power. When you raise a negative number to an even power, the result remains even. When you raise a negative number to an even power, the result remains positive. Okay, so let's just say positive raised to the power 4, because this is going to be like negative 1 multiplied by 4 times, so it will be to turn out to be positive 1. All right, great. So let's see what we have from here. So as you can see, 10 factorial is the same thing as, so maybe you can also learn how to evaluate factorials here if you don't. 10 factorial is the same thing as 10 times 9 times 8 times 7 times 6, right? I would like to stop there, but take note, you have to put a factorial. Normally, you keep on continuing. 6 factorial times 5 times 6 times 5 times 4 times 3 times 2 times 1 times 0 factorial, where 0 factorial is 1, right? So we have 10 minus 4, which is 6 factorial here. So if we like, we can just put it there, 6 factorial. And then we multiply that by 4 factorial, where 4 can be written as 4 times 3 times 2 times 1, right? Okay, so this is where we stop. All right, and then we have a raised to the power 6 times b raised to the power 4. So as you can see, some terms are going to cancel out nicely. This is 6 factorial, and of course, we have 6 factorial here. Take note, this is 6 factorial, and this is 6 factorial, not 6 factorial and 6, right? You don't cancel them like that. 6 factorial, you cancel. Then you notice that 4 can cancel out with 8 and will be left with 2 in place of 8. 2 can cancel out with 10. 2 can cancel out, cancelling 10 to give us 5 there, right? Times 3 will cancel itself. We cancel 9 and we'll be left with 3 there. 4 will cancel itself. To cancel 2, 8, we are going to be left with 2. Then 1, of course, it doesn't mean anything when it comes to multiplication. So we just keep it there. Maybe let me put this equality sign here. We just multiply this with 8 to the power 6 times b raised to the power 4. So we just have to compute this, right? We notice 5 times 3 is 15 times 2 will give us 30. Well, 30 times 7 is 210, right? So we're going to have 210 a raised to the power of 6 times b raised to the power 4. And of course, this is where we can say, we are done expanding. So this right here is the fifth term of the expansion of that, right? So this is a to the power 6, b to the power 4. All right, so that's just for the fourth question. Let's move over to the fifth, sixth, and other questions, right? Remember, 10 of them. McKay is here with you. All right, let's continue. Let's just wipe the board, and then we continue with the fifth and other questions. Okay, so this is the fifth question, and as you can see, I'm writing only this one, right? I haven't written the sixth question because this is going to really be fun, right? And the most interesting part is that I'm going to be showing all the working here. So all those simple squares and the rest, I'm going to do everything here, because this right here is 91 and this thing here is 40. So let's just see how we can get on with it. So we asked to find, without tables or calculators, the square root of this term right here. So let's just put it down as maybe let's just say the square root of this term, which is given to be 91 plus 40 times the square root of 3. Okay, now we have to find the square root of 91 plus 40 root 3, right? And this right here is a exotic expression. Okay, so what I'd like to do is to give us a form that our square root should look like, and then that form is going to contain like unknowns, so that we will try to find the unknowns. In other words, we'll try to get the square root of this exotic expression. So let's say let the square root be of the form the square root of a plus the square root of b, where a and b are numbers to be found, right? So maybe just put the word let. Okay, let the square root be that. So we want the square root of this to be of this form. So when we have a and b, we will now say the square root of this is equals to the square root of a, whatever a will be, plus the square root of b, whatever b will be. Okay, great. But you notice that from here, this begs to be squared because this is under a square root, right? So we will just have to square that. Then when we square that, we know that the square and the square root will cancel. We'll be left with 91 plus 40 times the square root of 3 will be, well, we are going to square this term. Now, take note from here, when you have the square of two terms, okay, maybe let me change this to x and y, right, so that it will not confuse us with what we have to take note of. So we just have to find x and y, right? When we square this term, right, we are going to have something like this. We're going to have the square root of x squared, just like we have here, right? Then we have to add it with the square root of y squared, right? Then we have to multiply them together. That will be 2 times the square root of x times the square root of y, right? Which we can rewrite it as 2 times xy. So you notice that the product of the square root is the square root of the product. That's why I'm putting this here like that, right? Okay, so let's see what we have. Well, you notice this is going to be on the right hand side. We are going to have, well, when you square root of x, we are just going to have x, right? Because the square will cancel out with the square root, and then we add it with, when we square the square root of y, we're going to have just y. Then we add this with 2 times the square root of the product xy. Now on the left hand side we have 91 plus 40 root 3. This right here is just a normal real number. We can call that a rational number if you like. You can call it a whole number because it is any of those two. But here we are having an irrational number because of this square root of 3. 3 is not a perfect square. So taking the square root of a non-perfect square produces an irrational number. And there is no way a rational number will become an irrational number. In other words, we will equate 91 to x plus y, and then equate 40 root 3 to 2 times the square root of xy, because the two things have the same form. That is to say, we will say let 91 be a plus b, and then, I'm using x and y. Now I'm used to a plus b. So let's just use x and y, and then we call 40 times the square root of 3 to be, 2 times the square root of xy. So if you like, you can call this your equation 1 and then 2. Okay, great. So you notice that from equation 1, okay, we can make x subject of formula. That means we're going to have x to be 91 minus y. That's just by subtracting y from both sides, all right? So you take note of this. Well, in the equation 2, we can substitute x in place of x, we can put in 91 minus y from this equation 2, right? So that means we're going to have 20 times the square root of 3 to be the square root of, so x is 91 minus y. So in place of x, I'm going to put in 91 minus y, right? Okay, so let's just cover that, and then we multiply that with y inside. So you notice we've just replaced x. Let me write this properly. You have x to be 90. Oh God. Okay, so we have x to be 91 minus y. Very nice, isn't it? As you can see, this is no longer 40, this is now 20. But you can also look at the right hand side, there is no 2 here anymore. So that means we divided both sides by 2, right? Okay, that's very nice. And now let's see what we have. Well, from this equation here, we can say let's raise both sides to power 2. So we raise this to power 2, and then we also raise this to power 2, right? You notice that 20 raised to the power 2 is going to be 400. This is where it gets crazy, right? That's going to be 400. Then we multiply that by what the square root of 3 squared is just going to give us 3, right? Okay, so we equate these two. Well, we have the square here. We'll cancel out with the square root, leaving us with 91 minus y times y, which we can expand y into the bracket. We're going to have 91y minus y squared. Great. So this now gives us a quadratic equation, which we need to find for the two values of y. Those values may be real values, complex values, or repeated real values. Let's just hope they are not going to be complex values, all right? Okay, so let's just see what we have. Well, we are going to rearrange this equation. We're going to have y squared minus 91y plus 1200 equals to 0. So you notice when you multiply this with that, we're going to have 1200 and positive. When we move negative y squared to the left hand side, we're going to have positive version of that, and then we move this to the left hand side, leaving us with 0 on the right hand side. So we're on the right track, right? So let's see what we have. Well, to solve this, I'm going to make use of well, we can factor this by factoring, but let's use the quadratic formula so that we can really see what's going on in here. So let's call y to be, using the quadratic formula, right? That is the almighty formula. Let's call y to be negative b, where b here is just negative 91. So that will be negative 91, negative of negative 91, which is just 91, plus or minus the square root of b squared. So you notice negative 91 squared, which is the same thing as 91 squared, right? Since we are raising a negative number to power 2, right? Hoping that this b is positive. If you raise a negative number to power 2, the result is the same thing as if you don't even put a negative in front of it. Because this is 2, negative squared will be positive, right? Negative of any number squared will be positive of that number. So we have this to be 91 squared. We have minus, negative b plus or minus the square root of b squared minus 4ac over 2a. So we have 4a here is just 1, c is 1200, right? Divided by 2a, where a is 1. Great. All right, so let's see what we have. Well, we have 91 squared here. So as I promised earlier that I'm going to do all the work in here. So in fact, I'll clean from the top, right, to the second to the last line so that we continue when I want to clean. So we're going to have 91. Maybe let's just see how we get everything done. Notice that 4 times 1200 is going to be 4800, because 4 times 12 is 48. Then we have 91 squared. Well, we can rewrite this as 90 plus 1 raised to the power 2. You notice 90 plus 1 is 91, right? And we raise it to power 2. We are going to apply this formula on that. That is going to give us, well, we square a, that is going to be a squared. So in this case, it's going to be 90 squared, right? We add it with, well, the next thing is to square the second number, which is 1 in this case. So the square of 1 is just 1. And then we add it with, well, the product of those two numbers with 2, right? So we're going to multiply 90 times 1 times 2. So that's going to be 180. Good, because 90 times 2 is 180. Okay, so we notice that, well, 9 raised to the power 2 is 81. So 90 raised to the power 2 will be 8100. And you are going to add 180 to that and also add 1 at the same time. So just add all of this together, you are going to have 8281. So this right here is the square of 90, right? Okay, so in place of 90 square, we are going to put in 8281, and 4 times 1200, as I said earlier, is 4800. So in fact, when I'm done cleaning, I'm going to replace everything with what I just said, and we'll continue solving. Okay, so let's see what we have. Now I've replaced what we had earlier with what we had as the results. Now we are going to take the difference, okay, under the square root. So we're going to have 8281. Okay, we subtract 4800 from that. Of course, this is just going to be 18. Okay, this is going to be let's just have that to be 43. So when you do that difference, you're going to have 3481. As I said, I'm going to show you all the work. Okay, so that's going to be 3481. We divide that by 2. Pooh. Now we have a bigger thing to do. What is the square root of 3481? We are not using calculator, right? Let's see. Well, the little trick I can show you here is this. You notice, you take note of the last number, the very last digit. The last digit there is 1. And besides, you take note of the first number, you take note of the number. That is the first thing you do. You take note of the number. This is 3,481. Well, if you square 50, we have 2,500, right? Let me cover this. Now, if you square 60, we have 3,600. So this number is 3,481, which is, in fact, very close to 60, but not up to 60 squared. Very close to the square of 60, but not up to 60 squared. That means that this number must be a square of some 50 something, maybe 50 something, right? Squared. Very nice. And you can see 3,481, very close to 60. Now, when we are done with that, we now look at this last digit here, which is just 1. Which number do we square to get 1 as its last digit? Well, if you square 1, you are going to get 1 as the last digit. That means we can possibly have 51. But you notice that this square is very close to 3,600, which means 51 will be far from getting closer to 3,600 like this, because it will be closer to 2,500. So, in fact, 51 is not good enough. So, which other number will we square to get 1 as the last digit? Well, if you square 2, you get 4. If you square 3, you get 9. If you square 4, you get 6 at the last digit. You square 5, you get 5 as the last digit. You square 6, you get 6 as the last digit. Square 7, you get 9 as the last digit. Square 8, you get 4 as the last digit. Then you square 9, you get 1 as the last digit, because the square of 9 is just 81. So in fact, 59 can be a very good one. So let's just square 59 and see what we have. So to square 59, we will do the same thing we did earlier by writing this as 50 plus 9, right? Well, 50 square is just, let me put it down here. 50 square is the same thing as 2,500. We add it with, well, 9 squared is the same thing as 81. And then lastly, we are going to multiply 2 times 50 times 9. Right? Just like this formula tells us. So 50 times 9 is going to be 450. That's because 55 times 4 is 45. And then we multiply that by 2, that would just be 900. So we see this to be, well, and when we add all of this together, we're going to have 3,481. So in fact, 3,481 is what we have here. So if the square of 59 gives us 3,481, that means the square root of 3,481 will be 59. So we are on the right track. So that must be 59, right? So we're going to equate this to 91 plus or minus the square root of 59. Sorry, no more square root, right? Because we just have 59 divided by 2. Okay, so we've gotten the, we are almost there. We've gotten the 2 values of y. So in fact, let's see what we have. Okay, so here we have y to be 91 plus or minus 59 over 2, right? So we, well, we just have to take 91 plus 59, then we take 91 minus 59. So this will be, well, 91 plus 59 is just 150, right? We divide that by 2, we're going to have 75, or 91 minus 59 is, we subtract, that will be 32. 32 divided by 2 will be 16. So in fact, those are the 2 possible values of y. So now we've gotten the values of y, we can use those 2 values to get their corresponding values for x. Alright, so let's see which equation. Let's make use of this. Okay, I cleaned the equation 1 and 2. Well, that's not a big deal because I can still recall them, right? I cleaned them when I cleaned the part of the board. We had one of the equations to be 91 is x plus y. In fact, this equation is enough. Okay, so when y is 95, right, we are going to substitute that back in there. We're going to get x to be, well, 91 minus 75 will be, that should be 16, right? We have x to be 16 when y is 75. And when y is 16, we will have x to be 75. Of course, just check that out. Okay, so that tells us that from this equation right here, let me clean this part. Okay. From this equation right here, that this square root will be, well, if we choose x to be 16 and y to be 75, it means we're going to have the square root of 16 plus the square root of 75. Okay. which if you like you can rewrite this as 25 times 3. That will be 4 plus 5 root 3. Okay, that is if x is 16 and y is 75. Or you can also look at these other cases when y is 16 and x is 75. You just plug in 16 in place of y, and that, in fact, the result will still remain the same because this is just addition. When we talk about addition, their order doesn't matter. Okay, all right. Anyway, so this is it. This is very nice, isn't it? So this right here is the square root of that. Oh, imagine how long it took, right? Okay, that was just the 5th question. In fact, let's clean the board and then we move on to the 6th question. Okay, now I want to answer the number 6 question. Now the question is, for what values of lambda does lambda minus 1x squared plus 4x plus lambda plus 2 equals to 0 have real roots? Alright, so we are to find the values of the unknown here, which is lambda. In this case, we are not to find the values of x, alright, because we are asked to find the value of lambda. So that this quadratic equation here will have real roots, right? Real roots. So there are times that the roots are not going to be real. In that case, I mean the roots are not going to be real numbers, okay? Be like complex numbers, or you can say complex conjugates. So we want to find the value or values of lambda that will make sure that this equation does not have complex roots. In other words, this equation have real roots. Okay, great. So I want you to notice something. This quadratic equation, this is like the a here, right? When you have ax squared plus bx plus c equals to 0 in the general form. This right here is the b, that is the coefficient of x, and this here is the constant term. Okay, great. Now when we're talking about roots of a quadratic equation, right, I want you to notice something. When we're talking about the roots of a quadratic equation, we have it to be, maybe x in this case to be, right, we have negative b plus or minus the square root of b squared minus 4ac, right, over 2a, where a is the coefficient of x squared, b is the coefficient of x, and then c is the constant term, which I've mapped out here. All right, very nice. Now, this right here will have real roots when the discriminant, this term inside the square root, right, is greater than 0, or is greater than or equal to 0. Okay, because if this term inside the square root is less than 0, we are going to have a negative number. That's what it means to be less than 0. And if we are taking the square root of something which is less than 0, it's like saying we are taking the square root of a negative number. Well, the square root of a negative number does not exist in the set of real numbers, right? So for us to have real roots, we must make sure that under the square root, we are either 0 or bigger than 0. That tells us that b squared minus 4ac should be greater than or equal to 0. This is only when we can have a real number as a result, right? So we are going to make use of that in that our question, keeping in mind that a is equal to, okay, so you notice that from the given question, a is lambda minus 1, right? B is 4, and then c is lambda plus 2. So we are just going to replace, let me write this well, lambda plus 2, right? So we are just going to replace a, b, and c with what they are here, right? And then we are going to use the same inequality, greater than or equal to 0. So that tells us that in place of b, we are going to put 4, and then we have to square that 4, right? Great. And then we say minus, well, 4ac, we say 4 times a times c. Anyway, let's just write it well. We have 4 squared minus 4 times a, where a here is just lambda minus 1. Okay, times c. C here is lambda plus 2. Right? And we have that to be what? Greater than or equal to 0. Okay, so we have to find the values of lambda that satisfy this equation. And of course, it's going to be that we're going to have like 2 values of lambda, which could be repeated, because this right here is going to give us a quadratic. So let's see what we have. Well, I'm just going to expand this right here. That means we're going to have 16 is here, right? 4 to rest of power 2 is 16, minus 4 times. When you expand this, we're going to have, notice this is how it's going to be. Say lambda to lambda, right? Lambda to positive 2, negative 1 to lambda, and then negative 1 to positive 2. So we're going to have lambda squared plus 2 lambda minus lambda, that just plus lambda, and then we have a minus 2 right there, okay? And then we say that is greater than or equal to 0. Okay, very nice. And now see what we've got. Let's expand this 4 to everybody inside the bracket. We're going to have this to be 16 minus 4 lambda squared, all right, minus 4 lambda plus 8, and this is greater than or equal to 0. Okay, so as you can see, we can maybe add some terms, right, like the 16 and the 8, and also at the same time I can say let's multiply through by negative 1. The reason is I want to get this lambda squared to stand in front, right, and be positive. So you multiply through by negative 1, keeping in mind that this is greater than or equal to 0, right? We are going to change the order of inequality. That means we're going to have 4 times lambda squared, right? We have plus 4 lambda, and then this plus that will give us 24, which we can just say negative 24 is less than or equal to 0. So if 5 is bigger than 6, then negative 5 is less than 6. But 5 is not bigger than 6, right? So if 6 is bigger than 5, then of course 6 is bigger than 5, then negative 6 is less than negative 5. That's why I changed this thing here. Okay, so we divide through by 4 just to make the quadratic equation look, the coefficients to look easy to deal with, all right? So if we divide through by 4, we're going to have lambda squared plus lambda, say minus 6 here is less than or equal to, divide 0 by 4, we're still going to have 0. So we have a quadratic equation to solve here, okay? And I'm going to make use of the factorization method, where I notice that on the left hand side, a quadratic inequality actually. On the left hand side we have negative 6, okay? So if I'm looking for 2 factors, when I multiply I get negative 6, and when I add I get positive 1. I'm going to think of 3 and negative 2, right? So I'm going to put this down as lambda squared plus 3 lambda. Okay, we're going to have minus 2 lambda, then minus 6, we say that's less than or equal to 0. Okay, so let's group and factorize, and it's just going to be very easy. This will be lambda plus 3, right? And then I'm going to factor out the negative sign together with 2, and we're just going to have lambda plus 3 left. So this is less than or equal to 0. Okay, great. And now let's notice that the bracket here is common, so we'll group and factorize, or we'll factorize the lambda plus 3, right? This is it here, and we are just left with lambda minus 2. This right here is said to be less than or equal to 0. So we have the product of 2 things being less than or equal to 0. All right, so we are going to handle this. So let me just clean from here down to the second to the last line, and then we'll continue solving. Okay, so here we have a quadratic inequality here, right? Where this is, which these are factors of the quadratic, and then we have that to be less than or equal to 0. Okay, great. So what we will do here is going to be really easy. We are going to look at what we call salient point, and by that I mean the critical point of this equation, and this is how we do. Okay, so you notice that if we substitute lambda to be 2, this right here is going to be 2 minus 2, which will be 0. So in fact, lambda equals to 2 is something we should take note of. And at the same time, if we substitute lambda to be 3, or to be negative 3, we notice negative 3 plus 3 is going to be 0. So we say lambda should be negative 3, take note of that. These are the points I'm talking about. So we have negative 3, which is less than 2. All right, so we've drawn a number line. You notice that negative 3 will lie on the left-hand side of 0, and then positive 2 will lie on the right-hand side of 0. That is if 0 is somewhere here. Now, towards the left side, we have negative infinity, and towards the right, we have positive infinity. So what we want to do is, since we've partitioned the real line into 3 segments, we are going to look at each of these intervals, right, to know if this one will satisfy this quadratic inequality, if this will satisfy all that. We just have to be careful with this, right? So you notice from the left-hand side of negative 3, we can choose negative 4, right? And then when we choose negative 4, let's see what we have. Well, we pick negative 4 from here. We substitute in place of lambda in this inequality. That will give us negative 4 minus 2, that's negative 6, all right? We multiply that by, well, negative 4 plus 3, that's negative 1. So we have negative 6 times negative 1. When you multiply 2 negative numbers together, the result will be positive, meaning that the result will be bigger than 0. But we are looking at this inequality to be less than or equal to 0. So if this product is going to be bigger than 0, which means this interval here does not satisfy the inequality. All right? Let's just do it again for you to see. Over this middle inequality. Sorry, over this middle interval. So we notice we have negative 3 and 2, right? We are going to pick a number inside here. So let's pick 0 because 0 is just easy to deal with. So you notice if we pick 0 for lambda, we're going to have 0 minus 2, which is just negative 2, right? And then we have times 0 plus 3, which is just positive 3. So if you multiply negative 2 by 3, you're going to have negative 6. And you notice negative 6 is less than 0. So since negative 6 is less than 0, it means this interval satisfies the inequality. So we are going to pick this interval. Very nice, isn't it? Okay, lastly, let's check over here. So you notice that between 2 and positive infinity, oh, it's not going to be the last anyway. Between 2 and positive infinity, we are going to, we can pick 3, right? Plugging 3 into here, we're going to have 3 minus 2, that is just 1. Multiply that by 3 plus 3, that is just 6. You notice this is positive, this is positive. The product of two positive numbers will remain positive. And since we are having that to be positive, positive is bigger than 0. So in fact, this right here does not satisfy the inequality because you want it to be either less than or equal to 0. Like I said, we are not done after looking at the third interval because we have to check at each salient point at 2 and at negative 3. In fact, they both satisfy because we got this root by equating it to 0, even when it wasn't an inequality. Even when it wasn't an equality. Okay, so let's substitute at negative 3 and see what we have. Well, when lambda is negative 3, you notice this is negative 3 plus 3, which will be 0. 0 times whatever we have here will be 0. And you notice 0 is not less than 0, but 0 is equal to 0. So since the inequality has an equality together with it, that means that this thing satisfies since it gives us 0 on the right hand side. Okay, and also here when we substitute 2, we get 0 out here. 0 times this will be 0. 0 is not less than 0, but 0 is equal to 0, so it still satisfies the inequality. So in fact, we have this to, from negative infinity to 3 to negative 3 does not satisfy. That is the interval here. From 2 to 3 with 2 excluded does not satisfy. That is the interval here. The only interval that satisfies is the closed interval from negative 3 to 2. So in fact, we are going to erase these ones. So that means we're going to have that if lambda belongs to this interval from negative 3 to 2. And as you can see, I'm using squared brackets, which means the salient point or these last points, right, are included. This means every real number from negative 3 to 2. So every real number, whole numbers, fractions, rational numbers, irrational numbers from negative 3 to 2. Lambda can be any of that. And when it is, this right here will have real roots. Okay, another way of writing this is, you say negative 3 should be less than or equal to lambda, and that should be less than or equal to 2. That is to say, lambda should lie in between negative 3 and 2 with negative 3 and 2 included. That means lambda can be negative 3 and it can be 2. That inequality will be satisfied, meaning that this right here will have real roots. Okay, that's very nice, isn't it? Okay, we're done with the sixth question. Let's just move over to the question number 7. Okay, and now we have the question number 7 to deal with here. It tells us to solve for x in this equation involving logarithms, right? Logarithm of 2x plus 1 to base 6, and that is equal to logarithm of 2x minus 1 to base 6, to base square root of 6, okay? Now, we are just going to do this real quick, but you notice that the right hand side is, in fact, complicated, and that is because of the base, right? Okay, so let's see what we have. Well, let me just put it out right here. We have the logarithm, right, of 2x minus 1 to base square root of 6. So let's see how we can handle the base a little bit. And in fact, I don't like that base. I would like to change it. And to do a change of base of logarithm, I will need a fraction line, all right? Then the next thing is to put the logarithm of this term here, 2x minus 1. And then I'm going to put something else here, logarithm of, in fact, this right here. This is how we set it up whenever we want to do a change of base of logarithm, right? We will now write a fraction, logarithm of this expression here divided by the logarithm of the initial base, or okay, you can say the original base. Okay, so when that is done, the next thing we'd like to do is to write down the new base we want. So in fact, I want my base to be the base 6, all right? So that to rhyme with what we have on the left-hand side. So I'm going to put in the base 6 right here. That means we're going to have, well, you notice that this is square root of 6, okay? I can write it as 6 raised to the power 1 over 2, because that's what it means to be a square root, right? The power there is just 1/2. So that means we're going to have and logarithm of 2x minus 1 at the top to base 6 right, divided by, you notice this is logarithm of 6 to base 6, right, where this is just 1/2, we can take it back right here. So we are going to be left with just 1/2 in the denominator, because logarithm of 6 to base 6 is 1. So taking the logarithm of 2x minus 1 to base 6 divided by 1/2 is like saying multiplying 2 by the logarithm of 2x minus 1 to base 6. That is, we are going to have this to be 2 times the logarithm of 2x minus 1 to base 6. This right here is very nice, isn't it? Okay, so that means in place of this, that is the right hand side, we're just going to substitute 2x minus 1 to base 6. Okay, so let me clean this up a little bit, and then let's put it down. Let's put that down. So we're going to have the logarithm of 2 base 6 of 2x plus 1, right? And this right here is the same thing as 2 times the logarithm of 2x minus 1 to base 6. That's what we have there. Okay, in fact, this right hand side is going to cause us a lot of trouble, and this is it. You notice that this is 2x plus 1, right, to base 6. Well, the values of x should not be less than negative 1/2, okay, or less than or equal to negative 1/2. The reason is, if x is maybe less than or equal to negative 1/2, you're going to have either logarithm of 0 or logarithm of a number less than 0. And that is not good for logarithms, right? Logarithm does not exist at 0, and logarithm does not exist at negative numbers. So we try to avoid a negative entry here. And on the right hand side, if x is less than or equal to positive 1/2, that is, x should not be less than or equal to positive 1/2. In other words, x should be greater than positive 1/2 for this thing to be defined. Because if x is less than or equal to positive 1/2, you're going to have this to be either 0 or negative, or a negative number, and that's not good for a logarithm. So we take note of this restriction here, right? This right here covers for the both sides. That's the left hand side and the right hand side. Okay, so let's see what we have. Anyway, that's just from the domain of logarithms. You just have to be careful. Now let's see, we have this right here. Well, you notice if I'm moving this to this top, this will become a square, right? Well, if this entry will become negative, the square will make it positive, which means we can have a result that we don't need. So, in fact, I would like to move it there, but keeping in mind we might have a result that we don't need. That tells us that at the end we will always verify our answers and see which one satisfies the original question. All right. So let's move this right here as always. So this left hand side will be the logarithm of this term 2x plus 1, right, to base 6, and then we equate this to the logarithm of 2x. 2x minus 1 raised to the power 2 to base 6, alright? So you notice this is an equality sign. The left hand side we have logarithm to base 6 of something. The right hand side we have logarithm of base 6 of something, right? So logarithm to base 6, logarithm to base 6, given that this is equality sign, these two must be the same. That is to say, 2x plus 1 must be the same thing as 2x minus 1, because that's only when these will be equal, alright? Since the logarithm, this is logarithm to base 6 and this is logarithm to base 6, as a student you can say, okay, let's cancel the logarithms and take the expressions, right? Okay, great. Now let's see, we are going to expand this right hand side, and when we expand it, we're going to have, well, let me put down 2, okay, it's not showing there, 2x plus 1, right? And let's equate that to, well, when we expand this using the binomial expansion, right, we're going to have 4x squared. We're going to have minus 4x plus 1. So you notice this is 2x minus 1. We are going to square the first term, which is just 4x squared. Then we are going to multiply these two by the first term and the second term, taking note that the second term has a negative sign. That means going to be 2 times 2x, that is 4x, times negative 1, that's just negative 4x. And lastly, you are going to square the second term, which is negative 1, together with, that is negative 1 squared, right? Together with the negative, that will become positive 1. Okay, so great. So let's see what we have. So this is going to be, well, I'm going to move this to the right hand side, thereby having 0 on the left hand side. So that means we're going to have 4x squared minus 6x, right? So because these two will become negative 2 when we come over here, and then we're going to have negative 2 minus 4x, negative 2x minus 4x, that is negative 6x. And then the positive one and the positive one will cancel themselves out. So we're going to have this to be equal to 0. Okay, great. It is common practice by students to move this negative 6 to the right hand side, thereby cancelling x. But that is very bad, right? Because by doing that, you are already losing one of the solutions. And Well, we will see. So we notice this is 4x squared minus 6x. We are going to factor something out on the left hand side. Instead of cancelling, let's do factorization. So we're going to factor out 2x because that's what is common, right? 2 is common in both 4 and 6, and that is common, and x is common here. So we're going to have 2x left on the first term, then minus just 3 left here. We equate that to 0. So you notice that 2x times negative 3 will give us negative 6x. Then 2x times 2x, of course, that's 4x squared. So we're on the right track. Okay, so we have the product of two things giving us 0. The product of this is 0 times this one gives us 0. That means one of them, at least one of them must be 0. Okay, so it's either 2x is 0 or 2x minus 3 is 0. So as you can see, 2 is not 0. That is, 2 is a non-zero number. So you are multiplying 2 with something, you get 0. In fact, that tells us that x is 0, because that's only when this 2x will be 0, right? So that's just by saying divide both sides by 2. So here we are going to add 3 to both sides and then divide the result by 2. That means you're going to have x to be 3 over 2. So in fact, these are the two values of x that we get by solving that. But you notice that when we started, we said that x should be strictly bigger than 1/2 for this thing to make sense, or for this thing to have real numbers when you substitute the solutions. So as you can see, if x is 0, the right hand side will be logarithm of -1 to base square root of 6. And having -1 in the entry of a logarithm is very wrong. So that tells us from this restriction that x should be bigger than 1/2. Of course, 0 is not bigger than 1/2. So that means x equals to 0 is not a solution to this problem. Okay, it's not a real value solutions to this problem unless we are asked to find complex results, right? Or results that can make the expressions complex. But if you are looking for results that will make this thing to be real, then x equals to 0 is not a solution. So the only solution we have which satisfies this inequality here is x equals to 3/2. So in fact, I would say the only answer to this is x equals to 3/2. Right? So you always try to verify your solution to see if it makes sense or not. Alright, okay, let's just move over to the next question, which is the number 8 question. Okay, and now I want to solve the number 8 question, which tells us to find P and Q given that this polynomial here, a quadratic polynomial, is divisible by x minus 1 and x minus 2. So in fact, I've written down a tool for us which will help us a lot, that tells us that if we are given a polynomial in terms of x, alright, then if we are given that x minus a number, a real number a, is a factor of that polynomial, that is to say, if x minus a number a can divide the polynomial, or you can say if the polynomial is divisible by x minus a, then x equal to a is a root. In other words, x equal to a will satisfy that given polynomial. Alright, so in this case we have this polynomial right here, and we have two factors of that polynomial, x minus 1 and then x minus 2. So given this tool, that means x equals to 1 from here, right? X equals to 1 will be a solution or a root, and also x equals to 2 will also be a root. So that tells us that if x is 1, this equation will be satisfied, and if x is 2, this equation will also be satisfied. So let's start with the first case when x is 1. So when x is 1, we are going to substitute 1 in place of x throughout, alright, on the left hand side and also the right hand side as well, if we can find x. I see what we have. So we're going to have 1 raised to power 4 will just be 1 there. We add it with, well, 1 raised to power 3 will be 1. We subtract, well, 7 times, negative 7 times 1 will just be negative 7. So in fact, I'd like to put down the negative 7 here. Okay, it was there before. And then the next thing we'd like to have is just plus p, because if x is 1, it doesn't change it when we are multiplying. And there's no x here, so we just put the q. And on the right hand side, there is no x, so we equate it to 0. So let's see what we have. So this is from the when x is equals to 1, right? Now when x is 2, right? From x minus 2, if x minus 2 can divide this polynomial, okay, that means x equals to 2 is a solution. That is to say, x equals to 2 will satisfy. So when x is 2, let's substitute 2 in place of x. We're going to have 2 raised to power 4. That is going to be 16, all right? We add it with 2 raised to power 3 is going to be 8. And then we're going to subtract 7 times 2, that will be 14. okay? Then we're going to add 2p, right? So we're going to say 2 times p. That is from the fact that x is 2, and then we add q to that, and then we equate it to 0. So this is like having an equation 1 and equation 2. Okay, so we're going to solve the two equations for the values of p and q. This right here is just a simultaneous stuff, right? So let's see how we can get on with it. Okay, so you notice that from equation 1, we can add some stuff, right? And by that, we're going to have 1 plus 1 to be 2 minus 7, that will be negative 5, okay? So we're going to have negative 5p plus q. So in fact, from equation 1, we're going to have p plus q minus 5 equals to 0, right? Then from equation 2, we're going to add this to that, that is just 24. We subtract 14 from that, that is 10. Then that means we're going to have 2p, right, plus q. We have this to be plus 10. We equate that to 0. Okay, great. So I'm going to solve this and that together. Keeping in mind that, let me put it from equation 1, all right? From 1, we get that p plus q is minus 5 is equals to 0. So if I, let's say, multiply equation 1, okay? Okay, let me say, yeah, let's use elimination method. I think that would be better. So let me do this. I'll say multiply equation 1 by 2, right? And then let's say we multiply equation 2 by 1. Okay, we don't need to change it. So we'll multiply equation 1 by 2. Take note, we're going to have 2p, right? That will be 2p plus 2q. Okay, we have minus 10 equals to 0. When you multiply the right hand side by 2, it just remains 0. Then we multiply equation 2 by 1, we'll still be left with 2p plus q, okay, plus 10 equals to 0. So what I'd like to do is, maybe let's call this equation 3 and equation 4. So what I'd like to do is to subtract equation 4 from equation 3, right? This is just 4. Subtracting 4 from 3, that is equation 3 minus equation 4. Okay, we're going to have, well, this minus that, this minus that, this minus that. That will give us 2q minus q will just remain q here. And then negative 10 minus 10, that will be negative 20, right? We equate that to 0. This tells us that q is in fact 20. Okay, very nice, right? We're just using the elimination method. Then since we've gotten the value for q, the next thing we'd like to do is to solve for p. And we can use equation 1 for that, given that p plus q, where q is now 20, right? Plus minus 5 is said to be 0. So if you subtract 5 from 20, we're going to have 15. And then when we subtract 15 from both sides, we're going to have p to be negative 15. All right? Because when we say 5 minus 20, 20 minus 5 will give us 15. That means p will be negative 15. So we've gotten the value of p and then the value of q. The value of q is 20, and then the value of p is just negative 15. Okay, great. All right, let's move over to the number 9 question. Okay, and now we have the number 9 question. So we want to find A union B cross A intersection B, given that A is a set containing elements x that satisfy this quadratic equation, and B is a set containing elements x that satisfy this quadratic equation. So what we really have to do is to get our set A and B, that is the elements of set A and B, and then when we're done, we compute the union, we compute the intersection, and then we take the cross product of the union and the intersection, and then we are done, right? So we need to solve this quadratic equation. The solutions we have for x, or those two values of x, if they are not going to be repeated, all right, are going to be the elements for a set A and also for set B similarly, right? So in fact, let's solve the quadratic right here. So we have the first for the set A, we have 2x squared minus 3x plus 1 equals to 0. Okay, great. So let's see, plus 1, right? So I want to use the factorization method, and I'm going to think of it, the two factors that will multiply together to get the product of 1 and 2, which is going to be 2. And then when I think of that, and I'll say, okay, this is a product, all right? The two factors, which when I multiply, I'll get the product of 1 and 2. So 1 and 2, the product of 1 and 2 is just 2. The two factors, when you multiply, you get 2, and then when you add, you get negative 3. So we have the two factors to be, let's say, negative 2 and negative 1, right? When you multiply negative 2 with negative 1, you get positive 2. And then when you add them together, you get negative 3. So this is what I'd like to do. I'll say, okay, that means our value of x will be, well, I will negate each of those factors. 1, I will divide it by the coefficient of x squared, which is 2. Or x will be, like I said, negate each of those factors. We had negative 2 as one of the factors and negative 1 as the other. I'm going to negate it. That means we're going to have to divide it by the coefficient of x squared. That is going to be 2. So we have 2 over 2 to be 1. So these are, in fact, the values of x. So this is from the set A. So we can say that as a solution, that the set A will be a set containing elements that satisfy this quadratic equation, which are 1/2 and 1. Okay, let's do for the set B as well. So in fact, let me clean this up. Okay, maybe we still have a little room. So let's see, we have x squared minus 5x plus 4 equals to 0. So what I would say is, we try to get the factors or get the solutions here. I'll use the factorization method as well. So we notice that this is 4. Okay, we need 2 factors and this is just 1. So these 2 factors, when we multiply, we get 4, and then when we add, we get negative 5. Well, if you get the 2 factors to be negative 4 and negative 1, you know the product will give you positive 4 and the sum will give us negative 5. So in fact, the values of x will be the negation of those factors. That is, instead of negative 4, we're going to have 4 divided by the coefficient of x, which is just 1. In fact, let's just keep it there, 4. Because if you divide anything by 1, you get that same thing, right? And then the other value of a will be 1, positive 1, right? Okay, great. So we have x to be 4 and then x to be 1. So in fact, let me put it down as 1, 4, okay? All right, great. So that means we have the 2 sets. So we now want to compute their union and then their intersection, and when we are done, we compute the cross product of the 2. So let me clean this up. So you notice that A union B will be elements that belong to the 2 sets, and repetition of elements is immaterial in the collection or in the set, right? So we're going to have 1/2 of 1, and then 4, right? So you notice that there is no point saying 1/2, 1, 1, 4 in the union, all right? Because 1 repeating more than once doesn't mean anything, all right? Okay, then we have their intersection to be, this is the union, the intersection to be, well, we want to find by intersection, we're talking about elements common to both sets, right? So that means we're going to be looking at 1, because 1 is common to both A and B. So it's just a singleton. That is an element, a set that contains only 1 element. All right, now that we are done with the union and then the intersection, we are now ready to finish this off by finding the cross product, that is the Cartesian product, right, of those sets. So say this cross that, A intersection B. Well, this will give us a set of ordered pairs of the form something here, comma something here, where the first entry will belong to the first set and then the second entry will belong to the second set. And then we can go on as much as we want. So let me see. Okay, I think we'll need up to 3, and you will see why. So this is how we are going to do it. You notice this is A union B, this is A intersection B, right? We'll take the first element and then pair it with the first element in this set. So it's going to be 1/2, 1. That is an ordered pair where the 1/2 belongs to the first set A union B, right? And then the 1 belongs to the second set, which is A intersection B. Then the next thing is, since we've exhausted all the elements, all right, using 1/2, we've exhausted all the elements in this second set, we will now get to 1 and then exhaust all the elements there, and then we will now get to 4 and then we put 1. This right here is a cross product of those sets. It is a set containing ordered pairs, right? Okay, that's very nice. So this is the solution. This right here is what is required of you. Okay, that was easy. Now let's move over to the number 10 question. Okay, now we're ready to solve the last question, and that tells us to express as the sum of partial fractions this fraction right here. That is to say, we want to decompose this into its partial fractions. All right, so we have the expression to be 3x squared, right, minus x, and then that is divided by x minus 2 here, right, and then 1 plus x squared. So when you're given a fraction like this to decompose, the first thing you want to notice is if the fraction is proper or improper, right? A fraction is said to be improper if the degree of the polynomial at the bottom, a fraction is said to be improper if the degree of the polynomial at the top is not less than the degree of the polynomial at the bottom, right? So in this case, let's see. Well, the degree of the polynomial at the top here is 2. What about the bottom? Well, it is not 2. Instead, it is 3, right? Because if you multiply these two brackets, the highest power of x that will appear will be x to the power 3 with 1 as its coefficient. So that tells us that since the power of the polynomial at the top is 2, which is less than the power of the polynomial at the bottom, in fact, this right here is a proper fraction. And if it is a proper fraction, we can just go ahead and decompose it directly, right, by just setting it up. So let's see how we are going to set this up. Well, we notice the factors we have. This is where we come towards the factors. Consider only the factors, right? Okay, for now. So we notice the factors we have. We have x minus 2. Let's put down the first factor, x minus 2. And then we have another factor, 1 plus x squared. Now, this right here is called a linear factor, which I've written out here, right? As you can see, the highest degree appearing there is just 1. So that's a linear factor. This right here is a quadratic factor. And since we are representing it this way, we can't reduce it to other linear factors. So this is an irreducible quadratic factor, right? When we have a linear factor, the numerator, we usually want it to be a constant. The reason is the numerator should be 1 degree less than the degree of the bottom, right? So if the degree of the bottom is 1, the degree of the top should be 0. So, and if you have a 0 degree, that means that's going to be a constant term, right? Now look at the degree of the bottom. The degree of the bottom is 2. In fact, the degree of the top must be 1, which tells us that the numerator must be, of course, a linear term. And we are going to use this form bx plus c just by following the alphabetical order, right? If you like, you can just put an addition sign there for now. Where is a, b, c are unknown constants to be found. Okay, when we find a, b, c, then we are done decomposing this to its partial fractions, right? That is how we go about it. So let's see how we can find the value of a. So you notice that here we are having a linear term, all right? When we have linear factor, we can use what we call the cover-up method. And this is how we go. First of all, check what value of x can make this denominator of a to be 0. All right, I'll look for the value of x, that when I put for this denominator x minus 2, I'm going to have 0. Of course, if x is 2, x minus 2 will be 0. So we keep in mind when x is equals to 2, right? What we do is, let me just put it down, when x is 2. I will cover up this term, right? Cover up that x minus 2 factor. And then substitute x equals to 2 wherever I find x in the other terms. That means we're going to have 2 squared here will be 4 times 3. That means that place will be 12. We say 12 minus 2. Of course, we're going to have 10 at the top. Let me just put it down here, 10. We divide that by, remember, we cover up x minus 2, right? Which is that particular factor we are trying to get 0 out of it. Cover it up, and then we substitute x equals to 2 here. We're going to have 1 plus 4 to be 5. So this place is 5. Well, we notice that 5 is 10 over 2 is going to be 2. Isn't that very nice? Let me see. 2 squared is 4. Okay, then that 12 minus 2, 10. Divided by 5. So we get 2 for a. That is the value of a by cover-up method, right? So you take when x is 2, not just for everybody, but when you cover this up here, and then substitute x equals to 2, when you get the result, that is in fact the value of a. Okay, great. So that's it. But can we do the same thing here? Well, no. This right here is not a linear factor, so in fact, it will not work for linear factors, all right? But we are still going to do something interesting. Now, you notice that since we are done finding the value of a, we now need to find the value of b and c. Well, first of all, if I try to eliminate the value of b from here by making x to be 0, you notice if x is 0, this term will become 0, meaning we just be left with c, right? So we will have a single equation with just one unknown. In fact, we can find the value of c, isn't it? So in fact, let's say when x is equal to 0. So when x is 0, we are going to substitute 0 in place of x, right? That means we're going to have 0 here minus 0. So the numerator will just give us 0 divided by, well, let's be a little bit careful. You notice that if the numerator of a fraction is 0, in fact, we are ready to have 0 as a result, right? But not when the denominator is also 0. So you make sure you don't have 0 in the denominator as well. So if you have x to be 0, that is when x is 0, negative 2, right? That place will be negative 2 times when x is 0 times 1. Of course, the denominator is not going to be 0. So that means the left-hand side will just give us 0. We equate it with Well, when x is 0, we'll substitute wherever I find x throughout, alright? Now we are not doing any cover-up method, so we are not covering anything up. So we will substitute for everybody on the left-hand side and then on the right-hand side. So when x is 0, notice a is 2 here. We'll have 2 divided by 0 minus 2, that is just negative 2. Okay, we add it with, well, when x is 0, it will eliminate this b term as well. We'll be left with c over 1 plus 0, which is just 1. In fact, I can just put it there as c. So notice that the left-hand side is just 0. This term is negative 1. So that tells us that 1 is equal to c. Alright? So when you get 0 here, negative 1 here, you move it to the left-hand side, become positive 1, and then you're just left with c on the right-hand side. So that tells us that the value of c is in fact 1. Right? So maybe let me put it down here as 1. Okay, very nice. Now let's try to solve for the value of b. So let me clean this up. Now to get the value of b, given that we have the value of a and c already, that means b is the only unknown, so we can make x to be anything, right? Let's say possibly it doesn't give us 0 in the denominator when we substitute, okay? Or doesn't give us big problems like choosing x to be 10. No, don't go that far, right? Just say when x should be maybe 1. 1 is simple. Say when x is 1, right? I notice that if you substitute 1 into any of these denominators, we will not have 0. In other words, we will not have to divide by 0, which will be undefined. So you notice that when x is 1, substitute 1 in place of x, we're going to have 3 times 1, that will be 3, minus 1, that will just be 2 at the top, right? We divide that by, well, 1 minus 2, that is negative 1 for the first bracket. We multiply it by 1 squared, of course, that will just give us 2 here. We equate that with, well, a is 2. 2 divided by 1 minus 2 is negative 1 at the bottom. And then we add it with, well, when we get 1 in place of x here, we'll just be left with b there. And then we add 1 to it, which 1 is from the c, right? Because c is 1. We say that divided by 1 plus 1 squared, which is just going to be 2, isn't it? Okay, let's see what we have. In fact, let me just change this to 2. Well, what I'd like to do here is to, maybe let's simplify things a little bit. Negative 1, 2 over 2 will give us 1. With the negative 1, we're going to have negative 1 on the left-hand side. This is equals to negative 2. All right, maybe add. I'm going to split the fraction at the same time. We're going to have b over 2 plus 1/2, isn't it? Okay, if you split the fraction, given that the denominator is going to be common for both numerators because they are separated by an addition sign. Okay, the next thing I'll do is to try and multiply both sides throughout. I'll multiply throughout by 2. We're going to have negative 2 to be negative 4 plus b plus 1. So we can just add the whole numbers and then we'll get our value of for b. So you notice this is negative 2. If we add 4 to that, we're going to have positive 2, and then we subtract 1 from that, we're going to have positive 1. In fact, that tells us that b, in fact, is equal to 1. Okay, that's very nice. So that is the value of b. That tells us that this fraction, the result will be decomposed into a over x minus 2, which we can call it 2 over x minus 2, right? Because a is just 2. So let's see. This is going to be 2 over x minus 2, right? Okay, we're going to add it with, well, b is 1 and c is also 1. So we're going to have x plus 1 because b here is 1, c here is 1, right? Divided by 1 plus x squared. We have 1 plus x squared. So this right here is the partial fraction for this big fraction right here, right? It's not hard to see. Just do some substitutions and get on with it, right? Okay, thanks for watching, and of course, you do well to subscribe to my channel, okay? Share this video with your friends, and I wish you good luck. All right.